Okay, so we left off on this previous problem, and remember to find the graphing region. We literally set whatever's inside my parentheses between 0 and 2 pi, and then we just solve for x here, solve for this middle, and that's how we would find the graphing region is between 0 and pi. And no surprise, this 2 is our b, so this is just a review of what we did last time. Because the sinusoidal function, a is the number out front, so this is like the first page of 4.4. A is amplitude. This b deals with the period, so if I wanted to find the period, how long it takes to do one cycle, I do 2 pi divided by b, so that's 2 pi divided by 2. So every pi, it's going to do a complete oscillation, a complete max 0, min 0, max, the total oscillation in 1. So if I want to talk about the frequency is the number of cycles the function completes in 1 unit interval. How many of you guys have heard of, like, if you're in physics, you know frequency because it's in hertz. So the human hearing range is 20 hertz to 20,000 hertz. So what that means is if there's something that's vibrating back and forth at 20 times a second, it's going to be a very low bass sound, and there's going to be literally 20 waves going into your ear per second versus 20,000. I mean, that's 20,000. And those are the really, really high pitch. And as you get older, you lose your the way your hearing works. Like, remember, it's a little like seashell looking thing inside your ear called the cochlea, and it's like little hairs that vibrate. Anyway, the shortest hairs that vibrate at the highest frequencies, you lose them. Highest frequency means like the fastest. Highest frequency means there's more of them per second. And so as you get older, you lose your hearing. This is why you shouldn't listen to loud music, because it literally will blast away your high pitch hearing. Anyway, so by the time you're about 25, you only can hear maybe 17,000 hertz, not 20. Little fun fact. So that's frequency. This is where it really comes into play. All of this stuff you can actually see in the real world. So I want you to see, like, why are we studying this? What the hell does this have to do with anything in your life? Oh, exactly. So when you walk around with your little beats on, and I can hear you from across the room, I know you're going to lose your hearing. Great. Okay. So frequency is how many times per second. Well, it says per interval. So if you're at the beach, maybe the waves don't come in every second, right? So you're like, okay, well, how about per minute? How many waves per minute? So I want to know the frequency, how many per minute? So that's why it says per unit. And so if you want to find the frequency, it's going to be the reciprocal of the period. So wait, if the period was 2 pi over absolute value b, the frequency is going to be the reciprocal. Sorry, frequency is that fancy little script F, which is going to be b over 2 pi. And don't forget it's absolute value, because if I have a negative sign in front, I got to take the negative away. Okay, so let's find the period and frequency of the given function. So period, 2 pi over b, frequency, b over 2 pi. All right, so sine of x. So what is my b here? Let's go through this as quick as possible. Ariel, what's the b? What's the b here? Exactly, 1, because the coefficient in front of x is just going to be a 1. So if I want the period, I have 2 pi over absolute value of 1, so that's just going to be 2 pi. And if I want the frequency, it's just going to be the reciprocal, so instead of 2 pi, it's going to be 1 over 2 pi. Beautiful, beautiful, beautiful. The next one, let's go with Cami. What is my b for part b? Awesome, 4. So it's the coefficient in front of the variable that we're taking the trig function of. So period, 2 pi over absolute value of 4. Well, that's just going to be 2 pi over 4. Well, surprise, 2 pi over 4 is the same thing as pi over 2. All right, because 2 and 4 have a common factor. And then if I wanted to take the frequency of that, that's just going to be the reciprocal, which is 2 over pi. Awesome. So phase shift of sine and cosine functions. Phase shift. So phase shift is the difference between the horizontal position of the function of that and otherwise a similar function. So it's kind of like we take it and we're literally shifting it over. So phase shift is your horizontal shift. This is your horizontal shift. So remember how we did a vertical shift? If we literally just, no, have we done that yet? I thought so. No? Because if I just add a number at the end, it's just going to move it up and down. It's kind of like if you had x squared versus, well, okay, let's think of something real quick. If I have x squared versus x squared plus 2, how do those two graphs compare? X squared versus x squared plus 2. Everything shifts up by 2. Versus, what if I had x plus 2 squared? Is that still shifted up? It shifts to the left. So in Algebra 2, you learned about parent functions, which is what this x squared is. It's parent function. It's like the simplest version of a squared, of a parabola. And so what you do is you take the whole function, and if you add 2, you're shifting it up. Versus here, if it's inside the absolute value, if it's inside the parentheses, inside the square root, inside the square, that's going to be your horizontal shift. And it's always, normally it's x minus h. And so since it's the positive, it goes the opposite way of what you think. So instead of going to the right, because hey, positive, it goes the opposite way, 2 to the left. So x squared looks like this, x squared plus 2, up higher, and then x squared, x plus 2 squared is just shifted over horizontally. So notice that this plus 2 is inside the square. So if I have something inside the sign of x plus 2, if it's inside the sign of with those parentheses, that's going to be a horizontal shift. And it'll tell us how much is shifting over. Is this board bothering you as much as it's bothering me? It's so dirty. They're going to throw away that red pen. Ugh. All right, so going back to what I wrote, those 3 parent functions, I'm trying to relate it to something that like you're pretty familiar with. So remember how we have y equals, I think it was like a x minus h squared plus k. That's the general like formula for a parabola where the vertex is at h comma k, and the h is the horizontal shift. And so if I have a positive inside, that means it's going to be shifting opposite of what I think, because normally it's a negative, here it's a positive, and then the k is going to be the vertical. So here we're talking about the horizontal. So notice this c is inside the parentheses of the function we're trying to, the trig function. So the phase shift is negative c over absolute value of b. So we're only dealing with the stuff that's inside the parentheses, because that's like we're taking sine of blah. It's whatever's inside, that's horizontal, and if it's outside, added, tacked on the end, that's going to be the vertical. So notice a phase shift moves the graph horizontally either left or right. Horizontally either left or right. So to find the phase shift, I'm going to give you 2 little steps to do. So to find phase shift. To find phase shift, first thing you want to do is you want to set bx plus c equal to 0, and then what you can do is solve for x. So literally you set whatever's inside the parentheses equal to 0. And when I say whatever's inside the parentheses, I'm literally talking about if I have sine of 5x plus 2, right? This inside the parentheses, I set it equal to 0. Right, because this is my C, this is my B. That way you don't have like a billion formulas to remember. It's like, okay, cool, set the inside equals 0. You can also set the inside the inequalities and solve, and then that tells me where I start and end. Try to make it as simple as possible. So here, I set that if I set this equals 0, 5x plus 2 equals 0. I see 5x equals negative 2, so x equals negative 2 over 5. So literally I'd have a phase shift of negative 2 over 5. So, cool. So graphs with horizontal translation or phase shifts. State the amplitude, period, frequency, and phase shift of each function, then graph. So first, let's hit the easiest one, which is amplitude. Who am I talking to yet? Let's have Jolie. What's the amplitude here? 2, exactly. So it's the number that's in front of your trig function. Daniel, what's the period? 2 pi? Yeah, because here the coefficient in front of the x is your b, and here it's just a coefficient of 1. Frequency, remember, frequency is the reciprocal of period. Audrey, what would the frequency here be?
1 over 2 pi.
Exactly, 1 over 2 pi. Just flip it. And then the phase shift, D's not here. Who am I talking to? Leah? Did I have you answer your question?
No.
Sweet. Let's do the phase shift. How would I find phase shift?
X minus pi equals 0.
Exactly. Set x minus pi equals 0, set the inside equals 0, and then solve.
X equals pi.
Exactly. So I have a phase shift of pi. So that means everything is shifted pi to the right. And guess what? If I found the phase shift was negative, everything would be shifting to left. So it's like we're all standing in a line, and it's like, okay, well, phase shift of pi, so I step to the right by pi units. Literally moving everything. I'm not stretching or compressing, I'm just sliding it over. Okay, so we have all this nonsense. So this is sine. I know I'm going to be stretching it like by a factor of 2, so it's going to go up to 2 and down to negative 2. I know I'm going to leave the period the same. It's still going to do 1 cycle over 2 pi, but everything's going to be shifted over by pi. So if I want to know what are the bounds of graphing, what am I going to be graphing? Where do I start? Where do I end? You set the inside portion in your inequality, so 0 less than inside portion less pi, x minus pi, less than equal to 2 pi, because normally we go from 0 to 2 pi for sine. So I want to know, for this graph, where I'm shifting it over, where do I actually start? Well, I have to solve for the x inside the inequality, so I add pi to all sides of the inequality, and then I go from pi is less than equal to x, less than equal to 3 pi. So I have this. I could have this be pi, and then I want 1, 2, 3, fourth line to the right of that will be 3 pi. If I want halfway between pi and 3 pi, be able to label it. Halfway between pi and 3 pi, that should just be 1/2 of 4 pi. No surprise, halfway between pi and 3 pi is 2 pi. And then I want halfway, so I just want to label all of my little axes. I want to label my tick marks. So halfway between pi and 2 pi, that's just 1/2 of 3 pi, or guess what? 3 pi over 2. Three pi over 2, and then hopefully we see this is 5 pi over 2. Halfway between 2 pi and 3 pi. Half of 5 pi is 5 pi over 2. Beautiful. So I have all 5 of my x values. And now I can just follow for sine. This is sine, so it goes 0, max, 0, min, 0. Little sick beat. Okay. So I start at 0. And then I go up to a max. Exactly. Don't forget amplitude goes to 2. So I go up to a max of 2, 0, max, 0, min, to negative 2, 0. Goes for sine, 0, max, 0, min, 0. So literally 3 of your points are 0, so that's rad. And then you just have to figure out what's my max. You look at the amplitude. Well, normally it goes up to 1, amplitude's 2, so I go up to 2. And I don't have a negative sign, so I don't have to flip it. It's just reg. So by figuring out our graphing region, we took care of the phase shift and the whole like, here's where I start, here's where I end, halfway between label, halfway between the midpoint and the beginning, halfway between midpoint and end. By labeling those, the spacing, I take into account the phase, the period, trying to make it as easy as possible.
Is there a difference between like sine and cosine waves, like everyone?
Well, it's cosine's a phase shift of sine. Every single cosine function can be written as sine because you just have to have a phase shift. It's a phase shift of pi over 2. So in reality, no, you can write everything as sine waves. Cool. I think that's all I want to say about this one. Okay. Awesome. This is a little bit harder. We can zoom through again. That'd be great. So let's go just top of the list again. Ariella, what is the amplitude for this problem? 4, because it's the coefficient front. Period, Jolie, what would be the period here?
The period would be 4 pi. Right?
Yeah. So real quick, 2 pi divided by 1/2, dividing by a fraction, same as multiplying by the reciprocal. Okay. So I'm hoping you're like chill with that and you understand. Otherwise, just, reiterating, making sure we're all on the same page. If the period's 4 pi, Cameron, what would be, Cammy, what would be the frequency? Beautiful, beautiful, beautiful. 1 over 4 pi. So that's how many, per second passes you. After 4 pi seconds, that would be 1 wave. And the phase shift, Leah. I think I had you do that last time.
Yeah.
All right. Awesome. Let's knock it out again.
X over 2 plus x over
Pi over 3 equals 0. No worries. So subtract pi over 3 on both sides. Subtract pi over 3. And then lastly, what do I need to do, Leah? Multiply by 2 on both sides. So I see the phase shift is negative 2 pi over 3. Because we set the inside portion equal to 0. Solve. I see I have a negative phase shift. So what that tells me is I take the whole cosine function, shift it to the left by 2 pi over 3. Okay, so I know my amplitude, and the number in front of cosine is a positive. So normally cosine is max, 0, min, 0, max. So if I'm starting at max, I know I'm going to be starting at 4. Just so we're all on the same page. We kind of see what the graph's going to look like. It's going to be stretched in both vertical and horizontal. Right? The period 4 pi is bigger than normal. Our normal is 2 pi. Our phase shift is to the left, so I'm going to stretch it vertically, stretch it horizontally, and shift it over horizontally. 3 translations. That's crazy. 3 things that we're doing. Okay, so.
Wait, how did you get negative 2 pi over 3?
So I set this inside portion equal to 0. It was x over 2 plus pi over 3. Subtract pi over 3 on both sides. So I have x over 2 equals negative pi over 3. Multiply by 2 to get rid of the divide by 2. So negative pi times 2 is negative 2 pi over 3. I should make this try to make that a little easier to see. Okay, the next thing I need to do is figure out my graphing area. So the graphing area, you set that inside, whatever's inside the sine or cosine parentheses. So here I set x over 2 plus pi over 3 less than equal to 2 pi. Okay, first thing I need to do, subtract pi over 3 from everywhere. From all the sides. So I have negative pi over 3 less than equal to x over 2 less than equal to, okay, 2 pi minus pi over 3. Well, that's 6 pi over 3, the same thing as 2 pi. So this portion, let me just, little side. 2 pi minus pi over 3 is the same thing as 6 pi over 3 minus pi over 3. I just made a common denominator. And to be clear, we only make common denominators if we're adding or subtracting fractions. If we're multiplying fractions, we just multiply across. Only make common denominator if we're adding or subtracting fractions. Okay, so this turns into 5 pi over 3. Awesome. Weird, right? It's a little weird because before we've stuck with 0 as our left side. But it makes sense. We had a phase shift of negative 2 pi over 3. So literally, everything is going over by, did I? No. Oh, done. I'm not done. I have to multiply the 2 out. But notice this is no longer 0, so I'm no longer starting at 0. Go through to get x by itself, multiply everything by 2. Negative 2 pi over 3, less than equal to x, less than equal to 10 pi over 3. So I don't need that. So I think when you're graphing, the easiest thing to do would be like draw that line halfway on your graph. And then I'm going to have just use the 4 lines. So here I'm just going to have this be my negative 2 pi over 3. And then 1, 2, 3, the fourth over is going to be my 10 pi over 3. Because this is always your start and your end. They're always on the first vertical line and the fourth vertical line. I don't know how to say that better. Okay, so now that I have the beginning and end, I need to figure out my other axes labels. I don't think that's the right term. So I want halfway, I want the midpoint, right? I want halfway between negative 2 pi over 3 and 10 pi over 3. Let's see, negative 2 pi over 3 plus 10 pi over 3, that's just going to be half of 8 pi over 3. That's 4 pi over 3. So halfway between is 4 pi over 3. All right, I need to find halfway. So I want to label this line. So it's halfway between negative 2 pi over 3 and 4 pi over 3. It's just halfway between my midpoint and my beginning. So negative 2 plus 4 is 2. So let's see. Half of 2 pi over 3 is just going to be pi over 3. Maybe we see the pattern. It's counting by pi. And then lastly, I want halfway between the 4 pi over 3 and 10 pi over 3. So it's just half of 14 pi over 3. So that's going to be 7 pi over 3. All right, do we have questions over how I did this one? I'm just figuring out the spacing. So your begin and end, all right, your beginning and end points, you give them the inequality, and then you go through and you find halfway between those. And then using that point, you find halfway to the beginning, use the middle point again, find halfway to the end. And now guess what? I have the 5x values for my, let's see, this is cosine, max, 0, min, 0, max. Just following through. Cool.
So on a test or quiz, would you give points for getting the correct intervals?
Yeah. Because this is the easiest way to do it. I wasn't so picky last year. I was like, you could do it this way, or you could like figure out, nah, this is way faster. Because people would be like, freeze up, or be like weird intervals. Make it the easiest. Okay, so we took into account the phase shift, right? Because this is where I'm going to be starting. I shifted my start. I took into account the period with my labeling. Because notice from negative 2 pi over 3 to 10 pi over 3, that's a distance of 4 pi. Well, that's the whole period. I'm going to do one complete cycle in that time. And now I just have to take care of my amplitude while I graph it. I think it'll get easier as we go through this more. So cosine, oops, I forgot to label my vertical. Let's have this be 1, 2, 3, 4, 0, 1, 2. I didn't put my y-axis, because it would literally be a third of the, like, my y-axis would be something like right here. Like it's not really needed, but it's one reason why I like gave you the graphs on your papers, so it's clean slate, so you can kind of like try the way we've been doing it in class. Okay, so for cosine, I started a max. Well, I have this amplitude times 4, so I have to multiply by 4, start at my max. And then 0, min. Well, normally I'm at -1, but now I have to go down to -4. 0, max. Awesome. Do you have questions over this one? I think I gave you the homework with this already, right? Okay. Okay, awesome. So on the schedule, what I wanted to get to today was 4.5. I'll at least start it, and let's see how far we can get. And then, blessed, I took a whole day where it's like reviewing 4.4 and 4.5. So if we don't finish these notes today, we finish them tomorrow, and then the rest of the time we'll be working on the homework, aka like that last page of the 2 worksheets I gave you. I'm sorry, we can work on them. Okay, I don't think it's too long. 2, 3, 4, 6, 7, 8 pages. Okay, let's try to get through 4. 4.5, graphing other trig functions. So recall that tangent is literally sine over cosine, right? Tangent is y over x, and sine deals with y. Cosine is x. Therefore, tan of x is undefined for all points where? Do we know? Where would tangent be undefined? So undefined meaning vertical asymptotes. What is, like, when do you say things are undefined? When you're dividing by 0. So tangent's going to be undefined when we're dividing by 0, aka whenever cosine of x, cosine of my angle is equal to 0, I'll be dividing by 0, and therefore tangent would be undefined. So when things are undefined, that's where they have vertical asymptotes. Oops. Does that make sense? So whenever cosine goes to 0, that means tangent is sine divided by 0. And then whenever you're dividing by 0, it's undefined, so that's where you have your vertical asymptotes. So literally everywhere where tangent 0, or cosine 0. So cosine 0 at pi over 2 and negative pi over 2. So guess what? At pi over 2 and negative pi over 2, that's where we have vertical asymptotes. Oh, sorry, I forget. You guys haven't seen this before. I need to like just take it a little slower. All right, so we have our unit circle. And let's think about where cosine 0. So we have these 4 points on our quadrantals. So this first point, you go over with x and y is 0, so this is 1, 0. Versus if you're on the y-axis, your x is 0 and your y is 1. If you go left on the x-axis, you're at -1, 0. And then if you're at this 273 pi over 2, well, you're on the y-axis, so your x is 0 and your y is -1. So if I'm looking for cosine is 0, I'm looking where x is 0. X is 0 at negative pi over 2 and 3 pi over 2 and pi over 2. Those are the 2 places where I'll be dividing by 0, so those are 2 places where I'll have vertical asymptotes for tangent. Versus, what happens at 0 and pi? Sine over cosine. Y over x. Y over x. 0 over 1 is equal to? 0 over 1. 0. Okay, so tangent is 0 at 0 and pi, and tangent is undefined with vertical asymptotes at pi over 2 and 3 pi over 2. So before we even look at the graph, I want to make sure like we know what we're doing. So here's like negative pi over 2, here's pi over 2, and I know I'm going to have vertical asymptotes here, because this is where cosine is equal to 0. Remember, negative pi over 2 is the same thing as 3 pi over 2. Okay, and I know it's 0 at 0 degrees. What happens to tangent as I go up through my unit circle, as I go around? So remember, tangent is 0 here. What about 45 degrees? What's tangent? Tangent 45. So 45 degrees, sine and cosine are the same number. So if you're doing sine over cosine, it's the same number over the same number. It's 1. Okay, so we go from 0 to 1. Okay. Do we know what tangent 60 is? Do you have your calculators? Like, let's just see what happens. Do like tan of 30, 60, see what's going on.
You said tan of 60?
Yeah, well first find tan of 30. We know 45, 60. So 45 we know is 1. 90 we know is undefined. So I just kind of want to have a glimpse of what's going on. So what is tan of 60 or 30? Who has one? 1.7. What about tan of 30? 0.5. Okay. So what is happening as I go from 0 to pi over 2? What's happening to tangent as I go around?
Going up.
It's going up, and then it goes undefined. Ooh. And then it's going to be going down. Oh, it's negative actually. Negative turns positive. Negative turns positive. So as I go from 0 to pi over 2, it goes up till it reaches an asymptote. And then I start really, really negative, and I increase till I reach 0, and then it's going to be increasing till I reach an asymptote. That's what kind of trying to show you here. So we said from 0 to 90 it's increasing, so it's going to look something like this. And if I did something where it was like tangent of 0, tangent negative 30, tangent negative 45, tangent negative 60, you would see that the other side goes down towards an asymptote as well. So that's what this is showing you. I just wanted you to like see it increasing in that first quadrant. It almost looks like a cube function. And notice the period is pi. Oops. Notice the period's pi. So I have these vertical asymptotes, and it repeats every pi. Okay, so we come down here. Let's practice. Notice the general form is super similar to a sinusoid, right? Here we already learned A is the amplitude. So what number are you multiplying every single point by? B, that's how you can find the period. Number 2 pi over B. And then the whole C, how do we find the phase shift? C helps you when you find phase shift, because you set bx plus c equal to 0. That's how you find the phase shift. And the last part, this D, is your vertical translation. So literally you're taking the whole thing, shift it up however many units. So if I'm adding to at the end, everything be added to. So vertical shift is your D. So it's very similar to the layout of sine and cosine. Difference for tangent. The period is pi, not 2 pi. The initial cycle, notice the way I highlight, we start at negative pi over 2 and we go to pi over 2. So the initial cycle starts at negative pi over 2 and then we end at pi over 2. So this is in comparison to sine and cosine. right, have a period of 2 pi and we start at 0 and we go to 2 pi, versus tangent, we start at negative 2 pi over 2 and go to pi over 2. That way we have one complete cycle of our graph. Otherwise, what we would have is it would look something like this. It would look like this, asymptote. Like this is from, well, imagine that this is 0 to pi. What? That's not nice looking. That's why we do from negative pi over 2 to pi, or pi over 2. That way it's one complete, like, smooth, continuous curvy line. Okay. So, to graph the tangent function, solve the inequality, negative pi over 2 less than bx plus c less than or equal to pi over 2. So this is what we were doing before, where we set our initial less than or equal to, the stuff inside, less than or equal to 2 pi, but that was for sine and cosine. Because for sine and cosine, we go 0 to 2 pi. Here, we're going from negative pi over 2 to pi over 2. So, the outer boundaries for my inequality, negative pi over 2 and pi over 2. Graph the asymptotes, find the midpoint within the period, plot the center point on the x-axis if there's no vertical shift, and then plot the points to the left or right of the center according to the value of absolute value of a. Okay, we're going to go through that and try to slow down just a sec. Are we okay? Are we a little overwhelmed? Let's just break it down. Let's go through the method. Okay. So these shouldn't be equal signs now I think about it, because tangent of pi over 2 is literally undefined. So I only want to be less than. My bad. Okay, first thing I'm going to do, locate vertical asymptotes. So I set the inside portion, well, it's literally only x here, less than or equal to pi over 2. Okay, cool. So once again, we're going to use the 4-line spacing. So if I have, let's see, draw a line here, that's not straight, draw a line here. If I say this is 0, if this is 0, 2 to the left would be negative pi over 2, 2 to the right is pi over 2. Because I'm using the 4-line spacing. Okay, so our first thing, solve the inequality. Well, there's nothing to solve. X is already by itself. We're cool. This automatically solves for the asymptotes. So this is beautiful because the ends are literally going to be our asymptotes. Our asymptotes are pi over 2 and negative pi over 2. Graph the asymptotes. Okay, cool. So graphing asymptotes is our dash line. Dash, 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 dashy, dashy, dash. Okay. So when I write VA, just stands for vertical asymptote. It's the only time I'll write it on a graph, so it's just a vertical asymptote. All right, so we graph the asymptote, check. Step 3, find the midpoint within the period. Sorry, I already did that. What's halfway between negative pi over 2 and pi over 2? Oh, 0. If not, don't worry, do not despair. Halfway between negative pi over 2 and pi over 2, that's just half of 0, so that's 0. Check, cool. So we find the midpoint, plot the center point on the x-axis if there's no vertical shift. Do we have a vertical shift? Nah, I'm not adding anything to it, so it's literally going to be at 0. And then I want to plot the points, the left and right of the center, according to the value of a. What's halfway between 0 and pi over 2? What's halfway? Pi over 4. Okay. Oops, I wrote. What is tangent of pi over 4? Literally tangent of 45 degrees. 1. Awesome. So I'm going to plot a point 1 to the right of the center, according to the asymptote, while according to A, my amplitude is 1. So I just multiply my 1 by 1. Okay, cool, so it's just 1. And then 1 point to the left, okay, so that's going to be negative pi over 4. And we know the value of negative pi over 4 is going to be negative 1. This is pretty much all the points you're going to be using when you're graphing tangent. So I come over here, do negative 1, and then I follow the asymptote up. and I curve it to touch my other point. I curve, follow the asymptote down. Beautiful. If I wanted, I come over here, state my units. Okay. Let's try the next one. Yeah? Yeah. So y equals 3 times tan x. Notice the change in the absolute value of a. So first, how is this graph going to be different than the one we just did? Do we have an idea? How will it look? Ariella?
Well, not looking wise, but
Let's see. So the only thing I'm changing.
oh no, it's gonna be higher.
Yeah, I'm just gonna be changing the amplitude. Yeah. No worries at all. So we're just recognizing. Literally, the only thing we do is just stretch it vertically. Otherwise, it's the same thing. Because if I go through and find and I set the bounds less than equal to x, well, I don't have to solve anything. I have the same horizontal spacing. I have the same asymptotes. But what I'm going to have different is the amplitude. So I have the same labels. Let's get negative. The only thing changing is the amplitude. So that's honestly the only thing is at the end. So this is 1, 2, 3, 0. Okay, so asymptotes. So the bounds, once you solve for x, that gives you your asymptote. Well, surprise, like we didn't have anything with x, so our bounds are just the regs, the regular ones. Here's my vertical asymptotes. Okay, step 1, solve inequality, solves for asymptote, check. Step 2, graph the asymptotes, check. Step 3, find the midpoint, already did that. We don't have a vertical shift because I'm not adding anything at the end. I'm not tacking on a plus number. So I'm gonna have 0 be my here, and then plot 1 point, 1 to the right. Okay, so literally pi over 4. We know tangent of pi over 4 is 1, but notice this is 3 times tangent pi over 4, so it's 3 times 1. It just shifts it, multiplies it by 3. Right? This amplitude is stretching it vertically. So instead of being at 1 as my y, it's now at 3. Similarly, instead of being at -1 with negative pi over 4, it's going to be at -3. So if we compare these two graphs, notice it's kind of like my brother and I both took the ends of the tangent and pulled. Right? We stretched it out, stretched it vertically. Because it's not so curvy and slow in the middle. It stretches out. Okay. Alright, let's try the next one, graphing reflections around the x-axis. Am I good to go on? I can stay here for a little bit longer if we need it. Alright. Do you guys feel, okay, do we feel confident? Do you want to try this yourself first? Yeah? Okay, try it yourself first and then I'll put it on the board. So, reflection on x-axis. Step 1, solve inequality. Step 2, graph asymptotes. Step 3, no vertical shift. So I'm just putting my little point at 0, 0. This last part is the hardest part. So by putting that -2 in front, because remember our amplitude's 2, we're stretching everything by 2, but that negative reflects it across the axis. So effectively, when I take -2 times tangent x, I'm taking -2 times my function, as long as my function was tangent of x. So I plugged in pi over 4 inside tan x, and then I'm multiplying by 2, because that will stretch it vertically, and the negative will flip it across the x-axis. Pause here. Do you have any questions? I think we're just finishing up. Okay, so try out example 3. Notice that we have a horizontal dilation and phase shift. So horizontal dilation, stretching horizontally, stretching or compressing. Phase shift, moving it over left to right. You should give it a try. So first step, solve the inequalities. Okay, so I have negative pi over 2 less than equal to 3x less than equal to pi over 2. Divide everything by 3. So I have negative pi over 6 less than x less than pi over 6. So this automatically solves the asymptotes for you. Negative pi over 6 and pi over 6. That's the wonderful thing about these inequalities. It solves it for you. It tells you where you start and you end. Cool. So I go over and I'm going to say that just draw a line. So we'll say this is negative pi over 6, and then 1, 2, 3, the fourth over is pi over 6. Okay, so step 2, draw your vertical asymptotes. Draw vertical asymptotes. This one's nice because I don't have a phase shift in this problem. All I'm doing is compressing it or stretching it out. I just have a horizontal dilation, so that's why halfway between negative pi over 6 and pi over 6 is 0. It's a nice little... And if I want to find halfway between 0 and pi over 6, divide by 2 when I add them, so it's going to be pi over 12 and negative pi over 12. Okay, so that I took care of the tan of 3x. I took care of that 3. All I did was, instead of going from negative pi over 2 to pi over 2, I'm now going from pi over 6 to negative pi over 6 to pi over 6. So this is a much shorter period. Much shorter period. All right, so I don't have a vertical, I don't have a plus or minus at the end, so it's 0. 1 over is always 1. I don't have an amplitude, so it's just going to be 1. 1 to the left, don't have an amplitude to multiply by, so it's just going to be negative 1. So here the difference is we actually had a change in our horizontal, what do you call it, tick marks? You know what I'm talking about? Spacing, it's another thing different. Okay, y equals tan of 1/3 x. So here, once again, solve for inequalities. And it will tell you automatically your asymptotes. So I must multiply everything by 3. So I have negative 3 pi over 2 is less than x, which is less than 3 pi over 2. So notice what we're doing is now we're stretching it out horizontally. Before it was only, negative 90 to 90. Now it's negative 270 to 270. It's much wider. But you're not really going to see that on our graph because the way we space out our axes. Three pi over 2 and negative 3 pi over 2. Okay, step 1, find asymptotes, check. Step 2, graph those asymptotes. 4 lines over, 1, 2, 3, 4. 3 pi over 2. Go ahead, graph them. Definitely let me know if I'm going too fast or if you have a question. So make sure it's logical. Do it yourself. Halfway between, well, negative 3 pi over 2 and 3 pi over 2, halfway between is going to be 0 because they're literally opposites of each other. And then if I went halfway between 3 pi over 2 and 0, it's just going to be half of 3 pi over 2, so that's going to be 3 pi over 4. So I have 3 pi over 4 and negative 3 pi over 4. Okay, so we have all of our spacings labeled. Tangent, here we go. There's no vertical shift, so put a point at 0 right in the middle. 1 unit to the right. I don't have my asymptote's 1, so I'm just going to go up to 1. If my asymptote was 4, I will go up to 4. Go 1 to the left, I go down to negative 1. Then you follow the asymptote, follow the asymptote. It almost looks like a cube function. Okay, cool. Too slow, too fast, just right. What are we thinking? Too slow, too fast, just right. Okay, cool. So make sure I'm not boring you with too many examples, but make sure we're getting it. Okay. Let's keep going. Ooh, interesting. We got like 2 things going on here. A, look, my number in front of tangent. I have this negative sign, so automatically I see it's going to flip it across the x. And then I have this plus pi over 2. So what that means is I'm shifting it horizontally. First step, set the inside, solve the inequality. So negative pi over 2. It just having this helps you solve. Helps you have to think less. All right, let's subtract pi over 2 everywhere. So I have negative pi less than x less than 0. Interesting, interesting. So my 2 endpoints, well, you know, the 2 ends of my inequality, those are my asymptotes. So negative pi and 0. Okay, solve inequality, check. Graph the asymptotes. I'm just going through the method, the 4 steps. First, solve inequality. Second, graph asymptotes. All of this being negative pi, 1, 2, 3, 4 over 0. Check. Okay. Found asymptotes, graph them, find the halfway point. So halfway between 0 and negative pi is just negative pi over 2. You can solve it this way. 1/2 times negative pi, which is negative pi over 2. And halfway between, let's see, negative pi over 2 and 0 is just 1/2 times negative pi over 2. So that's just negative pi over 4. Making sure we understand where this comes from. And then, not surprising, this last one's negative pi over 3. Negative 3 pi over 4. Okay, labeled. Don't have a vertical shift. There's no add or subtract at the very end. If I would, it would look something like this, like plus 2, right over here at the end. Has nothing to do with it's inside the tangent or being multiplied by. But I don't. I don't have a vertical shift. So my middle, right, the exact midpoint is going to be at 0. I go 1 point to the right. Normally I have a value of 1, but this is literally going to be negative times tangent of pi over 4 plus pi over 2. So I'm looking at negative tangent of 3 pi over 4. So 3 pi over 4 is 45 degrees if it's in the second quadrant. So normally it's going to be let's see, did I mess up? No. Oh, this is negative pi over 4. So this is just going to be pi over 4. Sorry. This is negative. I forgot the negative sign was there. Gotta make it clear. Negative pi over 4 plus pi over 2 is just pi over 4. 5 over 4 is 45 degrees. So it's just going to be negative times 1. Oh, literally it's just going to be negative 1. So this whole negative sign just reflects it across. So instead of going 1 unit to the right and 1 up, I go 1 unit to the right and 1 down. Similarly, this negative sign flips it, so I go 1 over to the left. Instead of going down, I go up. It's my bad, I can't read my own handwriting. Okay, so this is a pretty good stopping point. We covered a lot of stuff today. So tomorrow is, it says review 4.4 and 4.5. We'll finish the last 4 pages and then we'll spend the rest of the time working on homework, going over questions like that. So